Hello guys, evaluation metrics in machine learning. Let's go and discuss this. This is machine learning. So we have four learning types: supervised learning, which has classification and regression line; unsupervised learning, which has uh, clustering; and semi-supervised learning. It's between supervised and unsupervised; and reinforcement learning, which is actions, and we have rewards and observations. Let's go to evaluate how to evaluate each of these. So if each process or each learning type has some metrics for evaluate it. So the regression values has its evaluation, and the classification has its evaluation, and the unsupervised learning, which has classification clusteration, has its method for evaluation. But here we will learn together about supervised learning and exactly on classification. There are methods for classification evaluation. So it's if you have a problem, so it's you have a tools for repairing this problem, and you have tools for measurement of this solving. Okay, so this is the diagram showing that. Evaluation matrix, confusion matrix. This is called, which we learn together, is confusion matrix. Confusion matrix, you have to imagine or draw this diagram. You have patients and you classify it to diagnosed and not diagnosed. Okay, and we have patients who are sick, truly sick, and healthy. They are healthy. So you have here this column. The first is positive, so it's positive diagnosis, while the other is negative diagnosis. Okay, all positives here and all negatives here. Okay, for diagnosation only. And here we have true and false, and we have false and true. So true in this diagonal and false in the other diagonal. True positive and the true in its diagonal, and then false negative and false in these diagonals. Take another exam. This email, spam, not spam. Spam is positive, not spam is negative. Okay, so this true email, true spam, true positive. Okay, so this also will be true negatives, because this is a negative column, and here false, false. Okay, يبقى here positives, here negative, and here true, true, false, false. Okay, and we have two things: spam and email. Email, spam or not. Confusion matrix, how to calculate accuracy. Accuracy is true positive divided by plus true negative divided by all samples. So we have here is a true positive because this is a positive, and this is a true negative because this is a negative column, divided by all. So we have here 1,000 samples, we have 80%. This is accuracy. Now, how to calculate precision? Precision, this is precision, and we are mentioning all this. This is the dominant. This column will be in dominant, which is positive, 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 true, positive, negative, and in the other we have only positive, truly positive, true positive. This is called precision. True positive over true positive plus negative positive, false positive. Okay. Then we have the recall. The recall is true positive over two things, which are true positive with false negative. This okay. So we will see it again. We have the accuracy. We have two things over one thing. Two things is the true positive, true negative over all samples. Summation of all samples. Summation of all. Then we have the precision. The precision, true positive over true positive plus false positive. Okay. This is the precision. While in recall, we have true positive over true positive plus false negative. Okay. Then we have other matrix, which is F1 score. F1 score matrix. If we have the arithmetic mean as x plus y over 2, y is the precision, or say y is recall and x is the precision. Harmonic mean is 2 times x times y over x plus y. This is the harmonic mean, which is the F1 score. So harmonic mean is recall times the precision divided times 2 over precision plus recall. Then we have the beta. If beta score, this F beta score, if beta equals 0.5, f equals 1 beta, which is F1 score. If beta equals 2, we have beta equals 2. Okay, so F2 and so on. So F 0.5, F1, F2. Let's go to these equations and discuss how to calculate this matrix. So F beta score, how to calculate F0, beta equals 0, 1 plus beta square plus times precision times the recall over beta square over beta square for precision plus the recall. So if this is beta 0, we are precision times recall over recall. It's precision. It's pure. So F0 is equal precision, all precision, purely precision. If beta, note, if beta is really large, very large, so this is infinity, and this is also infinity. So we have infinity over infinity. It's 1, equal 1. 1 times the precision. And here we have 0 times the recall. So we have precision, recall, just purely recall. If beta very large, we have F beta, F equals recall. If 0 very small, we have F beta equals precision. The last thing, we will discuss the true positive rate and false positive rate. True positive rate is true positive over true positive plus F negative. So the positive over all positive cases. True positive plus false negative, which is sensitivity. True positive rate, which is sensitivity. Okay, sensitive. True positive over true positive plus Fn. If false negative is very small, so sensitivity will be high, will be over 99%. Sensitivity high. Specificity, اللي هي false positive, which is negative, false positive over false positive على true negative. So if this is very high, this will be specificity small. Okay, so we have this diagram. We calculate sensitivity and specificity for each point and process. If the area is large, it's good ROC curve. So ROC curve is drawn by true positive rate and false positive rate. Good ROC curve, which is receiver operating characteristics, ROC curve, will be ROC good. The area is larger, 0.8, while this diagram show us bad ROC, receiver operating characteristic, bad. Okay, so all depends on the true and positive and true false and false positive and false negative. All depends